right, let's jump right in. In this explainer, we're going to do a real technical deep dive into Cisco's wireless SD access. We'll get into the architecture, the key components, and the protocols that make it all tick.
Okay, so here's the game plan. We'll start with the why. The real benefits of integrating wireless into the fabric. Then we'll pull out the blueprints and look at the core architecture. After that, we'll pop the hood and see the protocols that act as the engine. Then, for the fun part, we'll follow a single packet on its journey. We'll wrap up by looking at different deployment options and, of course, the big payoff, the key takeaways.
So first things first, why even do this? We're going to look at the challenges this whole architecture is designed to solve and the massive benefits it brings to the table for both your wired and wireless networks. It's really all about creating one seamless, intelligent campus network.
And this diagram, it just perfectly captures the end goal, right? What we're talking about is a single, cohesive network fabric. The big idea here is that the policy follows the user, not the port. So, someone can unplug their laptop, walk over to a conference room, and hop on the Wi-Fi, and all their access rights and security rules just follow them seamlessly. It's that simple.
So what this all boils down to are 4 huge advantages. We're getting away from the old way of managing wired and wireless networks in separate little boxes. Now it's one unified operation. And that unlocks some seriously powerful automation, much smarter traffic flows, and makes rolling out new Wi-Fi services a whole lot easier.
All right, time to get into the nuts and bolts. Let's pull out the blueprints and meet the key players that make up the whole SD access wireless architecture. Once you understand what each piece does, the whole system just clicks into place.
Okay, this is the big picture, our master blueprint. We're going to keep coming back to this one. Just look at the distinct paths here. You've got CapWAP, which is for control traffic. You have VXLAN, which handles the actual user data. And then there's Lisp, which manages the whole control plane. This separation is exactly what makes the architecture so powerful and efficient.
So, sitting right at the heart of the control plane, we have the Fabric Wireless LAN Controller. You can think of it as the air traffic controller for all things wireless. It's really the brains of the wireless operation. So yeah, it does all the stuff you'd expect a WLC to do, managing client sessions, handling AP configs, all that good stuff. But here's the kicker. Its critical new job is to plug directly into the Fabric's Lisp control plane. This is how the WLC tells the rest of the fabric, hey, this wireless user is right here, making them a first-class citizen of the network. Next up, the Fabric Edge node. This is your on-ramp and off-ramp to the fabric. It's basically the bouncer at the door for both your wired and wireless clients, deciding who gets in and where they can go. Now, this is a super important point. The APs themselves, they aren't the edge nodes. Nope, they actually terminate their data tunnels on these heavy-duty switches. It's the fabric edge that does the heavy lifting of authenticating users, registering their location, and acting as that crucial default gateway for every connected device. And of course, you need the right gear to make all this happen. This slide gives you a look at the specific hardware that support it. For the controllers, we're talking about things like the Catalyst 9800 series. And for the access points, there's broad support, all the way from the 802.11 AC Wave 1 and 2 APs up to the latest and greatest Wi-Fi 6 capable Catalyst 9100s. Okay, let's get to the really cool part, the engine room, the secret sauce, if you will. We're talking about the core protocols that really make this fabric intelligent and dynamic. This is where the magic really happens. First up is Lisp. Now, don't let the name intimidate you. The concept is actually pretty simple. Think of it like a giant, super fast address book for the network. It separates who a device is from where it is. This is a total game changer for mobility. Because when a user moves, you don't have to rebuild complex routes. You just update a single line in the address book. And here's where it gets really clever. Check out how the WLC plays a role here. When a new wireless client connects, the WLC doesn't just keep that info to itself, it shoots a Lisp message right over to the control plane, basically saying, hey everyone, the client with this MAC address, he's now hanging out at this Fabric Edge switch. Just like that, the entire fabric knows exactly where to find that user. All right, so if Lisp is the who and where, then our second protocol, VXLAN, is all about the how. This is our data plane protocol. The best way to think about it is like putting our data packets into a special envelope or a tunnel to carry them across the underlying physical network. In this diagram, man, it just lays it all out perfectly. This shows the fundamental change in how we handle traffic. Your control traffic, that still goes back to the WLC through a CapWAP tunnel. But the user data,
That's the big news. It gets sent directly from the AP to the local switch inside a super efficient VXLAN tunnel. No more hairpinning all your traffic back to a central controller. That old bottleneck is gone. Okay, so we've met the players, we've looked under the hood at the protocols. Now let's put it all together. Let's follow a single data packet on its journey from a wireless user over to a wired one. This is where it all clicks. So, a packet zips through the air from your laptop to the access point. What happens next? Well, the AP acts like a super-fast mail clerk. First, it tears off the wireless-specific packaging, that 802.11 header. Then it shoves the original packet into a new VXLAN envelope, addresses it, and sends it on its way across the fabric.
And here you can see that transformation happening right before your eyes. The original IP packet is now tucked away inside all these new headers. And look at the destination IP on that outer header. It's not the WLC, it's the local fabric edge switch. This is local traffic switching at its finest.
But wait, the real magic? The secret ingredient is baked right into that VXLAN header. This is where the AP stamps the client's policy information, their virtual network ID, and, most importantly, their scalable group tag, or SGT. You can think of the SGT as a security badge that says who you are and what you're allowed to access.
And that, right there, is the most crucial point to understand. The policy literally travels with the packet. So when the fabric edge switch gets this thing, it just rips open the envelope, reads that SGT badge, and knows exactly what to do, which security rules to apply, which routing table to use. It's consistent, automated policy enforcement everywhere. Okay, so now that you've got a handle on the how, let's talk about the practical side of things. There are really two main ways you can go about integrating wireless into an SD access fabric. It's good to know your options, especially if you're planning a migration.
So on the left here, you've got the full-blown, true fabric integration that we've been talking about with that awesome distributed VXLAN data plane. Then on the right, you have what's called the over-the-top or OTT model. Here, the fabric is really just being used as a transport network to carry those traditional CAPWAP tunnels back to a central non-fabric controller.
This table really nails the differences. The recommended path, for sure, is the full SD access wireless model on the left. It's what gives you that optimized performance and scalability. The OTT model, think of it more as a stepping stone during a migration, or a way to get a third-party wireless system to work over your fabric. It works, but it's not the end game.
All right, let's bring it all home. We're going to circle back and summarize the huge advantages you get when you go with that true native wireless integration. This is really the payoff for putting all these pieces together.
So, at the end of the day, this architecture really does deliver on the promise of software-defined networking. You get the whole package, full automation, incredibly granular security segmentation using SGTs, and, this is the big one, a single unified policy for every single user and device, whether they're wired or wireless. Plus, you kill those old performance bottlenecks for good. So, we'll leave you with this question to chew on. Now that you've seen the blueprint, how could this kind of unified fabric totally transform the way you handle security and efficiency on your own network? The potential is massive. Thanks so much for joining me for this deep dive into Cisco's wireless SD access.